Astonishing Pluto was discovered by astronomer Clyde Tombaugh in 1930, the ninth in order. When still a planet, it was named in honor of the god of the underworld, Pluto. The planet's orbit takes the shape of an elongated ellipse with a significant slope of 17 degrees to the flat plane of motion of the other planets. A complete revolution around the Sun takes Pluto 247 years, and intermittently, for periods of almost 20 years, it happens to be closer to the Sun than Neptune. Pluto's diameter is 2,374 kilometers. Pluto's mass is almost 6 times less than the mass of the Moon. It weighs 480 times less than the Earth, and its diameter is 2/3 that of the diameter of our natural satellite. Pluto's atmosphere is very thin and consists of gases evaporating from surface ice. This was perhaps all we knew about Pluto. However, on July 14, 2015, everything changed. On that day, the New Horizons space probe flew past Pluto at a speed of 50,000 kilometers per hour. The flight to the destination took the spacecraft 9 years, 5 months, and 27 days. In total, the craft covered more than 4.5 billion kilometers. Thanks to this mission, researchers have obtained high-quality images of Pluto and made many discoveries. Among other things, they have discovered cryovolcanoes on its surface, have postulated the existence of a subsurface ocean, and discoveries continue to be made to the present day. For example, the directors of the New Horizons mission finally managed to completely record and decipher the last portion of research data that had previously been obtained with the help of the super-powerful space telescope mounted on the probe. Indeed, we are hurrying to share it with you. It turns out that the subglacial oceans of Pluto are one of the most interesting places in the solar system from the standpoint of the existence of conditions for life are concerned, with the exception of Europa. However, so far very little is known about how they formed and what is happening in them under the multi-kilometer shell. But all the same, the results of the survey were a real surprise to the mission's directors. No one had imagined that distant Pluto would not look at all like a smooth billiard ball, but would have an extremely complex relief, reflecting the history of its origins. In the new images, Pluto turns out to be covered with recently formed mountains, ice plains, methane ice dunes, and even icebergs drifting through nitrogen. In addition to that, the ice crust of the celestial body is strewn with countless cracks that looked like traces of recent tectonic activity. They were the first indication of the existence of a giant subsurface ocean on this dwarf planet. Soon other evidence emerged supporting the presence of liquid water under the planet's icy crust. But how and when it originated on Pluto remains a mystery to this day. But we now know that at one time, Pluto was originally cold. This means that it grew slowly, accumulating ice material from the outer solar system, and at first there was no ocean on it. Water in liquid form only appeared on Pluto after the core of the dwarf planet warmed up as a result of the radioactive decay of aluminium-26 and gravitational interactions with its satellite, Charon. In this scenario, geologic faults in the celestial body would have retained signs of surface compression. Why compression specifically? The fact is that the heat emanating from the depth of the planet would melt the lower layers of the ice, turning it into liquid water, which, as you know, takes up less space. As a consequence, Pluto's ice crust would have begun to contract, which would lead to the formation of distinctive geological traces. And what have we learned about Pluto's atmosphere and climate? Pluto's atmosphere is predominantly composed of nitrogen, with minor traces of methane, ethane, ethylene, and other gases. It is extremely thin. It has a pressure about 1,000 times less than that of the atmospheric pressure on Earth. Nonetheless, it has great influence not only on the climate, but also on the geology of the dwarf planet. For example, it facilitates the equalizing of the temperatures of the different regions of Pluto, and because of the greenhouse effect created by methane, the temperature of the planet's surface increases. Also, new data have demonstrated that some segments of the surface of the dwarf planet actually have snow caps, which are formed in a completely different way than they are on Earth. If on Earth, we are often able to observe the conversion of clouds into snow on mountaintops since temperature decreases with increasing altitude, then on Pluto there is conceptually the inverse process. Since the atmosphere there becomes hotter as the altitude increases, correspondingly, the physiochemical traits of the process of the formation of snow and snow caps on Pluto differ dramatically. In this case, calling it methane ice is the most accurate conclusion. And finally, it turned out that the change of seasons on Pluto occurs not because of the tilt of the planet's axis of rotation as on the Earth, but is due to the elongated orbit. Over the course of a revolution around the Sun, which takes roughly 250 Earth years, the amount of heat received by Pluto changes almost 3 times. As a result, the density of the atmosphere fluctuates significantly. In the long summer, which lasts a little less than half of the Plutonian year, the frozen gases evaporate, and in the winter, they again revert to a solid state. They evaporate from the most brightly lit and warmed areas and settle in colder areas. This process ensures that gases are carried over the surface of the planet and over millions of years have sculpted the most amazing forms of relief. What comes next? New Horizons has raised more new questions for us than it has cleared up old ones. But most unfortunately, no new missions to Pluto are planned for the near future. So it will be a long time before we get new information comparable in value to that which was received from New Horizons.